In this section, we'll be discussing the matrix multiplication property. That is, matrix multiplication is not commutative. So if you have two matrices and you change the sides and multiply, they won't be equal. So A times B will not be equal to B times A. Let's take an example. So let's say we have two matrices, that is A here and B, and we want to multiply them. So A, the size of A is 1 times 5, and the size of B is 5 times 1. As since the last number of the first matrix, that's the number of columns, is equal to the first number of the second matrix, which is the number of rows. If they're equal, we know that this matrix multiplication is possible. But the result matrix, that is the result matrix, the size of the result matrix is 1 times 1 here. Now if you change the sides, that is, if you make it B times A, so if you make it like B is 5 times 1 size and A is 1 times 5, so again these two numbers, they are equal, so this matrix multiplication is possible. Now if you look at the result matrix, here you have 5 times 5, 5 times 5 as the number of rows and columns. So as you can see over here, this here has 1 row and 1 column in the result matrix, and this one here has 5 rows and 5 columns. So they are nowhere equal. So as you can see over here clearly that A times B is not equal to B times A. Let's do this with elements, this example. So let's call this as example 1, and let's say we have two matrices here, A and B, and A is a 1 times 5 matrix. So let's say the elements are 1, minus 1, 0, 2, 3, and the matrix B, the elements are 1, 0, 2, 3, 4. Now if you multiply them, you get your answer here as the row multiplied with the column here, right? So you will get here 1 times 1 plus minus 1 times 0 plus 0 times 2 plus 2 times 3 plus 3 times 4. That's all. It's a 1 by 1 matrix, so this will be equal to, I'll make these smaller so I can fit in the answer here. So this is equal to 19. That's one element, right? So that's a 1 row times 1 column matrix. Now if you make it the other way around, that is B times A, so you will have here now 1, 0, 2, 3, 4 times the matrix A, which is 1, minus 1, 0, 2, 3. And if you multiply these two here, so you will get a 5 by 5 matrix as we just discussed here. So here you multiply the first row, that's just 1, with the first column, then the first row with the second column, and so on, and you get a matrix that looks like this: 1, 0, 2, 3, 4, minus 1, 0, minus 2, minus 3 minus 4, 0 0 0 0 0 2 0 4 6 8, and then you have 3 0 6 9 12. So that's a 5 by 5 matrix. That's 5 rows and 5 columns. And as you can see here, this two matrices, that is A times B and B times A, are nowhere equal. They just don't look equal because look at the number of elements. They're having a huge difference. Okay, now let's take another example. Example 2. So let's say we have two matrices, A and B. So A is 2 1 0 2 and B is 3 1 0 minus 1. So this time we took the same matrix, same size I mean. So you have a 2 by 2 matrix here and the 2 by 2 matrix here, right? So now if you have A times B, right? So the previous example 1, the difference was in the size of the matrix, and now for example 2 we'll see about the difference in the elements. So here we have A times B. So you have A is 2 1 0 2 times B, which is 3 1 0 minus 1. That gives you the answer here as 6 1 0 minus 2. And B times A, we have 3 1 0 minus 1 times A, 2 1 0 2, and this gives you the answer as 6 5 0 minus 2. So now if you compare A times B, that is this one here, and B times A, that's this matrix here, you will see that the first element is same, 6 and 6. That is, you can say the element at row 1 column 1 is same as here the element at row 1 and column 1, the same position. And then the at row 2 and column 1, here and here both the element is same, 0 and 0. So goes for this element here, that is row 2 column 2 and row 2 column 2, the matrix, the elements are same. But then there is only one element that's different, that is row 1 column 2 row 1 column 2. Only one element is different. So here you can say that let's call this, let's say X and Y. So we say that X at row 1 column 2 is not equal to Y at row 1 column 2, and therefore A times B, or you can just say X is not equal to Y. What is X? X is actually A times B and Y is B times A. They are not equal. Proved again with elements. Now even if you have the matrix, result matrix sizes as same, here 2 by 2 and 2 by 2, but if the elements are different, of course the result is not the same, and so they can never be same. That's what it says. Matrix multiplication is not commutative.